In 1903, a group of workers digging a drainage ditch in Somerset, England, hit something in the ground. A skeleton, nearly complete, 10,000 years old. They named him Cheddar Man. For over a century, he sat in a museum display case, Britain's oldest known resident, the face of early European humanity. Paintings of him showed a pale figure, a kind of founding ancestor for the people who came after. Then in 2018, scientists finally sequenced his DNA, and the results were so unexpected that they ran them twice. Cheddar Man had dark brown to black skin and blue eyes, not pale, not the color of the British Isles today. Dark, like someone from sub-Saharan Africa, with eyes like a clear winter sky. The researchers weren't prepared for that. The public wasn't prepared for that. And if you sit with it for a second, it raises a question that's harder than it looks. How did human skin go from universally dark, literally every human on Earth had dark skin not long ago, to the spectrum we see today? The answer doesn't start where you think. It doesn't start with geography, or sunlight, or anything you'd find in a social studies textbook. It starts with a decision about what to eat for dinner. Let's back up 2 million years, because this story needs a starting point. When our ancestors still had fur, skin color barely mattered. Fur did the heavy lifting. It blocked UV radiation before it could reach the skin underneath. If you shaved a chimpanzee, you'd find pale skin. The fur is the protection. The skin doesn't need to do anything. Then, around 2 million years ago, we stopped having fur. Not overnight, over hundreds of thousands of generations, in response to a hunting strategy that would have cooked any furry animal alive. Persistence hunting. Running prey to death under the direct African equatorial sun for hours at a time. Thick fur is excellent insulation in the cold. It is a death sentence when you need to shed heat at full sprint. The hominins with less fur sweated more efficiently, hunted longer, ate more, survived. And the moment that fur was gone, the skin was exposed to the full force of the equatorial sun for the first time in primate history. The body's response was immediate, in evolutionary terms. Melanocytes, the cells that produce melanin, ramped up. Melanin is essentially a microscopic shield, a pigment that absorbs UV radiation before it can penetrate deeper and damage your DNA. The more melanin, the darker the skin, the more protection. Over hundreds of thousands of generations, natural selection ran hard in one direction. By the time Homo sapiens emerged in Africa around 300,000 years ago, every single one of them had deeply pigmented, melanin-rich skin. Not most of them, all of them. Dark skin wasn't a variation. It was the only option that kept you alive under an African sun. This is the baseline, the starting point, the default setting for every human being who ever lived before anything else happened. Now here's the thing about melanin that most people don't know. It does two things simultaneously, and those two things are in direct tension with each other. The first thing, it blocks UV radiation, protects your DNA, keeps cancer away. Good. The second thing, UV radiation is also how your body makes vitamin D. Not just vitamin D, like a supplement you take in the morning. Vitamin D is technically a hormone. It regulates calcium absorption, bone development, immune function, reproductive health. Without enough of it, your skeleton doesn't develop correctly. Your immune system misfires, and in women, critically, the pelvis doesn't form the shape it needs to for childbirth. In equatorial Africa, this tension didn't matter. The sun was intense enough that even with melanin blocking 90% of UV, the remaining 10% was still more than sufficient to synthesize all the vitamin D you'd ever need. Then, around 60,000 years ago, some of those dark-skinned Africans started moving north. The Sahara had temporarily greened. Wet periods turned it into grassland, opened natural corridors. People followed animal herds. Competition for resources pushed groups further into unexplored territory. Generation by generation, the migration crept northward. And somewhere along that journey, a physics problem appeared. At high latitudes, the sun doesn't rise high in the sky. Its light travels through far more atmosphere before it reaches the ground, and that atmosphere filters out most of the UVB radiation, the specific wavelength that triggers vitamin D synthesis. In a northern European winter, which can last 6 months, meaningful vitamin D production stops almost entirely. Doesn't matter how long you stand outside. Dark skin evolved to block 90% of UV. In Africa, with extreme UV levels, 10% getting through was plenty. In Northern Europe, where UV levels might be only 10% of Africa's, dark skin now lets through maybe 1% of what the body needs. That is not enough, not even close. And the body's response to chronic vitamin D deficiency doesn't announce itself. A child growing up without enough vitamin D doesn't collapse, doesn't look visibly sick. They eat, they play, they seem fine. But inside, quietly, the skeleton is going wrong. Bones that should be dense and hard stay soft. The pelvis, specifically, doesn't form correctly. And when that girl grows up and tries to give birth, the geometry doesn't work anymore. The baby cannot pass through. This is where vitamin D stopped being a health issue and became an evolutionary filter. Every generation, the same brutal math applied. Women with slightly less melanin produced slightly more vitamin D. Their skeletons developed slightly better. They survived childbirth at higher rates. Their daughters inherited the same reduced melanin production. Repeat for 10,000 years. This is not a metaphor. This is exactly how natural selection operates. Invisible, gradual, completely indifferent to anything except who survives long enough to have children, who survive long enough to have children. But here's the thing that stopped geneticists when they first looked at the timeline. If this selection pressure existed from the moment humans arrived in northern latitudes, 40,000, 50,000 years ago, the math predicts that pale skin should have appeared in Europe within a few hundred generations. It didn't. As recently as 10,000 years ago, Cheddar Man's era, most Europeans still had dark skin. For 35,000 years, the selection pressure existed. The filter was running. And almost nothing changed. Why? The answer, when it finally arrived, came from the last place anyone expected. Lunch. Hunter-gatherers weren't relying on sunlight alone for their vitamin D. They were eating fatty fish, animal liver, eggs, marine mammals. Foods that are naturally dense in dietary vitamin D, dense enough to compensate for reduced sun exposure, even through a 6-month northern winter, even with deeply pigmented skin. The melanin didn't need to change because the diet was doing the job instead. Dark-skinned hunter-gatherers in northern Europe were fine. Not thriving in terms of UV exposure, but fine because they were eating things that quietly solved the problem the sun couldn't. For 35,000 years, diet was the safety net. The vitamin D crisis existed on paper, but not in practice. And so the selection pressure that should have been rewriting skin color was doing almost nothing. Then, 10,000 years ago, the safety net disappeared. Agriculture arrived in Europe from the Near East, and it transformed the human diet faster than almost any previous change in history. Grain became the staple food: wheat, barley, millet, the caloric backbone of the new farming lifestyle. And grain contains virtually no vitamin D, none, no matter how much of it you eat. Now, you might wonder, if hunting and fishing solved the vitamin D problem, why didn't early farmers just keep hunting and fishing on the side? Because farming doesn't work that way. Early agricultural life wasn't a peaceful upgrade from hunter-gatherer life. It was brutal, relentless, season-locked labor, planting, tending, harvesting, protecting fields from animals and competitors. You couldn't afford to send people away on multi-day hunting expeditions. Fish were available if you lived near a river or coast, but for inland communities, the logistics didn't work. By necessity, not choice, the diet became grain-based. And the one thing that had allowed dark-skinned humans to survive in low-light environments for 35,000 years was gone. Now the selection pressure became acute. No dietary backup. Weak sun. Dark skin blocking 90% of what little UV existed. The same filter that had run at low intensity for tens of thousands of years suddenly slammed to full power. Women with slightly lighter skin, just slightly, produced just enough vitamin D to get through pregnancy safely. Their daughters survived. Their darker skinned neighbors, no dietary safety net, chronic vitamin D deficiency, structurally compromised pelvis, they didn't. Generation after generation, not over millions of years, over thousands. Within the span of recorded history, what accelerated it was a single mistake. Deep inside one cell, in a gene called SLC24A5, a copying error occurred during DNA replication. One letter changed, out of 3 billion in the human genome. This mutation reduced melanin production by 30 to 40%. One person, somewhere in the Middle East or Southern Europe, we don't know exactly, was born noticeably lighter than everyone around them. Not a little lighter, noticeably. And in the environment they were living in, with a grain-based diet and weak northern sun, they were healthier for it. They had more children. Those children were lighter. They had more children. Within roughly 150 to 250 generations, somewhere between 3,000 and 5,000 years, that single copying error had spread through European farming populations almost completely. Not through culture, not through preference, not through anyone deciding anything, because the people who carried it kept surviving long enough to pass it on, and the people who didn't increasingly didn't. Here's the part of this story that still stops me. East Asian populations also developed lighter skin at northern latitudes in response to similar low UV environments. Same problem, same evolutionary pressure, same direction of change, but they carry almost none of the SLC24A5 mutation that turned Europeans pale. They used different mutations, different genes, different molecular pathways, same result. Biologists call this convergent evolution, when completely separate lineages facing the same environmental problem independently arrive at the same solution. It's the same process that gave dolphins and fish nearly identical body shapes despite being separated by 95 million years of evolution. The environment poses a problem. Natural selection finds whatever path it can to solve it. Sometimes it finds the same answer twice. What this means is that pale skin is not one thing that happened once. It's a solution the human body independently invented at least twice, driven by the same equation: low UV, grain diet, vitamin D crisis, selection pressure, mutation, survival. Let's go back to Cheddar Man. He died around 10,000 years ago, at the very beginning of agriculture's arrival in Europe. His dark skin made perfect sense for a hunter-gatherer eating fish and game in northern latitudes. His diet was compensating for everything the sun wasn't providing. 1,000 years later, his descendants had switched to grain. The safety net was gone. 5,000 years after that, the SLC24A5 mutation had already spread through the region. Cheddar Man's blue eyes, still present in some British people today, are a remnant. His dark skin, almost entirely gone from that population, was erased not by time, not by race, not by any human decision, by a change in what people ate for dinner. Think about what you're carrying around in your body right now. Your skin color, whatever it is not primarily about where your ancestors are from in any cultural or political sense. It is a record of what they ate, what latitude they moved to, what crops they grew, what UV levels their bodies were forced to adapt to, and which copying errors in their DNA happened to be useful at the time. The pale skin that now dominates Northern Europe didn't exist 10,000 years ago. It was created by agriculture, by grain, by a vitamin D crisis, by a single mutation within the last few thousand years. In geological terms, last Tuesday. The dark skin that every human being on Earth once shared wasn't lost. It was replaced, population by population, under specific pressures, through specific mechanisms. And in populations that never shifted to grain agriculture, or that lived in high UV environments where the change would have been deadly rather than helpful, it stayed. Melanin didn't change because humans changed. It changed because lunch changed. That's it. That's the whole story. 10 million years of evolution, one copying error, a field of wheat, and the face staring back at you from the mirror this morning.